Section 17.2, page 253, deals with solving quadratics by factorising. Again, nothing new, just the same as Unit 2. So question 1, let's have a little starter. It says this: x squared plus 17x's plus 72 comes to 0, okay? Two factors equals 0, x and x. 72, right, 17 might go into 72, so get a calculator quickly. So 72 divided by 17, that doesn't work at all. Oh, how silly, 8 times 9, 8 times 9, there we go, both positive. So x squared, 9x, plus 8x is 17x's, altogether, 9 plus 8 is 17, and 8 times 7 is 72, how silly of me not to see it. Therefore, both parts, x plus 8 is 0, therefore x is minus 8, and x plus 9 is 0. Again, we're just solving, x equals minus 9. Two solutions to this quadratic equation. Let's just do C. Z squared. They like z's, look like 2's, don't they? 10z minus 24 is 0. Two factors multiplied together make 0. Z and z, how do you make 24? That's going to be 2 and 12, or 12 and 2. To make positive 10, I need plus 12 to make 12 z's, and minus 2 to make minus 2z. Let's check it. Z squared minus 2 z's plus 12 z's is 10 z's, and 12 times minus 2 is minus 24. So I've got z plus 12 is 0, there it is. So z is going to be minus 12, give me a grade B, and z minus 2 equals 0, and z equals 2. You can see why I don't like z's, they look like 2's. Let's just do E, shall we, up here. It says here b squared minus 2b equals 15. Well, that's no good to us. Bring it over to the left hand side. Minus 15 equals 0. Two factors equal to 0. B and b makes b squared. How do you make 15? 5 3's or 3 5's. Give me a difference of 2. Look, minus 2 there. So I want b squared. B times 3 is 3b. So let's have a positive one there. And 5 times b is 5b. But I want it to be negative, because if I end up with minus 5b's plus the 3b's, I've got my minus 2b's that I want. And again, look, minus 5 times plus 3 is negative 15, so that's fine. So I've got two parts as shown, and therefore b is going to be 5. Take it over and plus it. I've got b plus 3 equals 0, and b equals therefore negative 3. Take minus 3 over and minus it. Last one I won't do. Question 2 looks really good, so it's the first one with a bit of a shape to it. Right, just turn over nice, that'd be good. There we go. Right, triangle. I've been given a triangle with something like this. Draw it nice and big. I'm told this is x plus 5, the base length, and the height from there to there is x. It really is the height, but I'm not drawing it beautifully. Alright, so the height is from top to bottom. And now I've got to do something. The triangle has the dimensions shown. The area equals 42. So better write that down. Would be centimetres squares, wouldn't it? Since I'm given dimensions in centimetres, that's x centimetres and x plus 5 centimetres for the base. Write down a quadratic equation for the area of the triangle. Okay, so half times base times height equals 42. Don't like this half, so let me just get rid of it. So x plus 5 multiplied by another x equals, take the 2 over and multiply, we have 84. Alright, looking a bit nicer, isn't it? So multiply this out a little bit. X squared plus 5x is 84. Bring my 84 next door and subtract. That equals 0. Solve your quadratic and find the height of the triangle. So x is the height. If I get a solution for x, then that's fine. Now, two brackets, only grade B. X and x. Now, how do we make 84 to get a difference of 5? 6's. Don't know, just play with it a minute. I can't think straight. So 84 6/14 actually works, but 6 and 14 won't give me a spread of 5. I'll pause and get back to you. Right, so 12 and 7 makes 84, and have a 12 there and a 7 there, and then decide where the signs go. Well, x times x is x squared, x times 7 will give me 7x's. If I go negative on the 7x's and positive on the 12x's, I've got 12x minus 7x is 5x, and 12 multiplied by minus 7 goes to minus 84, so that's fine. So I've got two parts to this. I've got that, therefore x is negative 12, and I've got x minus 7 equals 0, and therefore x equals 7. Now we can only take the positive solution to be as a valid height, because you won't have a height of minus 12 centimeters. It doesn't make sense. So therefore, let's write the solution up here. Height x equals 7 centimeters, and that's all there is to it. Again, I know we create a quadratic, but sometimes one of the solutions won't make any sense in reality. We won't have a negative length. Okay, the height is 7 centimeters, a positive 7 centimeters. Question 3, that I might pause to do some more challenging ones. So question 3, I've got to solve these. We're into grade A and A star now. Let's just pick B for example. I've got 8y squared minus 18y plus 9 equals 0. No common factors, just got to get on and solve it. We'll factorize it first and then we'll solve, alright? Trouble is, 8 is of course an even number. I can split it up with 4 and 2, 2 and 4, 8 and 1, 1 and 8. 9 can be 1 and 9 or 3 and 3. Don't know how it's going to go yet. So let's just take a wild guess. If I go for 4y and 2y, and if I go for 3 and 3 makes 9, let's see if we can get somewhere. Right, there's my 8y squared. There's my 12. Yep, that's 12 y's, and 3 2's is 6. 12 and 6 makes 18. I think I've got it in one. They both have to be negative, because I want minus 18 y's. And please note, minus 3 times minus 3 makes plus 9. Let's just test it, 'cause it's quite tricky. Well, again, 4y times 2y, I've got my 8y squared. 4y times negative 3 minus 12y. 3 times 2 is 6, but it's negative 6y, and minus 3 times minus 3 is positive 9. Check it. That and that is minus 18, so that's happy, that's great. Therefore, ignore all this green stuff. I've proved that it's correct, so now I'm going to go and solve. So what have I got? I've got 4y minus 3 is 0, so 4y equals 3, from which y becomes 3/4. Okay, that's one solution. The other one, 2y minus 3 is 0, so 2y equals 3, so y equals 3 over 2, otherwise known as 1 1/2. Okay, second solution. I'll get one more down this side now. Oops, just cut through it, never mind. Just wind back the video and see what's underneath there. That was B done. Ignore C. I think I'll do D. Looks a little bit strange, so I'll do it. 2x squared minus 0.5 equals 0. If I double it up, it just seems nicer somehow. Let's see if I can go for 4x squared minus 1 equals 0. Look at this, I've got the difference of 2 squares. Look at that. 2 squared is 4, 1 squared is 1. I'm glad I decided to double up, because I would have been in big trouble. Right, let's just produce my two factors. So 2x times 2x makes 4x squared. 1 times 1 makes 1. So that could be positive, that could be negative. Just test it. 2x times 2x, 4x squared. 2x times negative 1, well, that's going to be minus 2x. And 1 times 2x is plus 2x. As you can see, they cancel. And 1 times minus 1 is minus 1. So I've got two solutions. I've got 2x plus 1 is 0. So 2x equals negative 1. X equals minus 1 over 2 minus a half. This side, 2x minus 1 also equals to 0. 2x equals 1, from which x becomes 1/2. There's my two solutions. Lovely. I think I'll be brave and try F. It looks terrifying. but I'm going to do it anyway on the other page, and then probably pause for some more quadratics involving pictures and problems and that sort of thing. So this is 3f, and I'll stop after this one, put it right in the middle here. So I've got 3p squared plus 16p plus 7 equals minus 14. Again, don't want that over here, bring it over and add it. So I've got 3p squared, 16p plus 7 plus 14 comes to 0. Simplify. 3p squared, 16p plus 21 equals 0. No common factors, so let's just get factorising, shall we? There it is. The easy part is the only choice I have is to go for 3p and p and nothing else. 21 is likely to be 3 7s. If I put a 7 there and a 3 there, 21 take away 3 won't give me 16, so that didn't work. Let's get rid of it. What if I put the 7 there and the 3 there? That's going to work. Look, 9p's plus 7p's, 16p's. Easy. As you can see, I took a wrong turn. It wasn't deliberate, I just tried it out, and I realised it was wrong, so I self-corrected. So here we go. 3p squared plus 9p plus another 7p, 16p, and 7 3s are 21. So here are my two possible solutions coming up. So 3p is going to be negative 7, p is going to be minus 7 over 3, do it properly, so p is going to be minus 2 and the third. 3 goes in 7 twice, 1 left over. This one's easier, so p plus 3 equals 0, so p is going to be minus 3. Two solutions, both equally beautiful. So I'll stop this video, and that'll be enough for 17.2. Then I'll study some of the ones involving pictures and word problems, and I'll get back to you quite soon.